So I'm going to have a look at this next puzzle here, this next simplification of Boolean algebra. Let's do, as we've done before, decompose the problem, start on whichever side you want. What I'm going to do is I'm going to start on this side and get my marks for actually showing how I would simplify this. So let's go, I've got a not b, okay, but then that becomes a b, but then that becomes a not b again. So I've ended up with a not b. We've got and, which becomes or, which becomes and. Okay, so what you should be ending up with there is the same. If you see 2, it stays the same, okay, as it currently is. Again, we've got an A, so we knot the A and we take it back to how it was. You'll notice that there is nothing above this sign here. Okay, so there's nothing above this and because of that, what I'm going to do is flip the sign. So I'm going to do A plus. Not B becomes B plus A dot B. So I've got not B and A, or B, or A and B. Now that's one step. Now I want to take that a little bit further and I want to break this down and make it a bit more simpler. There's a number of approaches that you might want to take on this. The first thing I'm going to do is I'm going to look at the and, which takes precedence. See the and symbol as a multiplication. Multiplication always takes precedent over the plus. So what I've done here is I've gone over to my laws, looked at the absorption rule, and this becomes a B. Okay, so B or A and B becomes B. Now that's going to leave me with not B, A or B, because that is what's become of that. Alright. Now believe it or not, there is another absorption rule that you can apply here. This becomes A or B in its simplest terms. Now you're probably thinking, how on earth have you done that? Well, I'm going to show you how that absorption rule has worked with a truth table here. Okay. Now, what you've got to remember is the dot takes precedence. So if you're going to put this into a table, you're going to need to remember to work out this bit first, which I'm going to show you now in a little table here so you can see how I've got that. So I've just worked out what our final answer is, and you can see A or B is 0, 1, 1, 1. What I've done is A, B as my inputs, and I've worked out that only 1 needs to be true in order for the outcome to be true. So we know that A or B is 0, 1, 1, 1. Now watch what we're going to do. I've just put a not B there, so I've negated that, so that becomes a 1, that becomes a 0, that becomes a 1, that becomes a 0, just so you can see how the absorption rule works here. Now, we go again, this time we're going to say not B and A. So 1 and 0 is 0. Okay? So I'm doing the multiplier, I'm doing the and first. Okay, I'll keep calling it a multiplier because it helps you when you're doing some of the harder simplifications. So we've got not B, 0, and A, 0 and 0 is a 0. Not B is 1, and A is 1. Because they're both true, the outcome's true. Not B, 0, and 1, the outcome is 0. We're not done yet. Now that we've got that, because this took precedence over it, we're going to OR it to a B. So 0 or 0 is 0. Okay. 0 or 1, because it's in 1, the outcome is 1. 1 or 0 is 1. And 1 or 0 is 1. If you look now, you can see that these are exactly the same. So B and A or B is the same as A or B. And that's just to demonstrate how the absorption rule worked with the not B, with the B, and the A. So that's just to demonstrate how it works in terms of a logic gate. See that as the multiplication symbol, if you like, if it helps you understand it better. When you work on this side first, always work with the AND first and the OR second, then you're able to work out and see what the outcome would be. And that is how I broke down this equation into A or B.